Welcome. This is the Understanding the Vector, or V Standard webinar, a resource for SDSFIE training. This training resource is designed for a general audience. Viewers need not have any prior familiarity with SDSFIE or its components. The 3 background training resources listed here are optional, but they may add to your overall understanding of SDSFIE. Note that what is SDSFIE is an abbreviated version of the more detailed SDSFIE program overview presentation. The overall goal for our training resources is that all SDSFIE users understand the purpose, structure, and parts of the SDSFIE family of standards, or standards framework. The specific objectives for this presentation are that the audience gains an understanding of the following: what SDSFIE is and what DoD components are involved, what SDSFIE Vector, or V, is, what its purpose is, and how it is implemented, SDSFIE-V data model terminology and process, the logical data model hierarchy, implementation guidance, the vector standard mandate and recent versions, model elements and terminology, element properties, the adaptation process, and the SDSFIE portal, your point of entry for accessing standards, tools, policies, and guidance. SDSFIE is an acronym for Spatial Data Standards for Facilities, Infrastructure, and Environment. The FIE thus represents the different types of data in the installation, range, and training space that our standards encompass. The definition of SDSFIE provides both its structure, a framework for a family of standards governed by the Installation Geospatial Information and Services Governance Group, or IG, supported with online tools, technical support, and training, and its purpose: meeting the DoD goal of making installation and civil works geospatial data and services visible, accessible, understandable, linked, trusted, interoperable, and secure, or VALTIS, across the DoD. In the last decade, SDSFIE has evolved in a number of ways. This includes expanding from the single vector standard to a family of standards, with the additions of the now mature quality, metadata, and raster standards, and the emerging portrayal and endorsed standards. The IG is composed of DoD components that include the Army, Navy, Air Force, Marine Corps, the Army Corps of Engineers, and the Washington Headquarters Service. The IG is chaired by the Geospatial Information Officer, or GIO, for the Assistant Secretary of Defense for Energy, Installations, and Environment, and is supported by the Defense Installation Spatial Data Infrastructure, or DISD, program. SDSFIE-V is a content standard for vector geospatial data. SDSFIE-V provides a shared, standardized schema for the types of geospatial entities and their characteristics, or attributes, which are used in Installation Geospatial Information and Services, or IGINS, and civil works missions throughout the DoD. To be clear, a content standard does not in and of itself contain any data records. Rather, as a consensus data content standard, it provides an agreed-upon structure for the database containers that hold actual data records. This is not unlike a set of spreadsheets, each with well-defined and agreed-upon column headings, but without any values populating the rows. The purpose of SDSFIE-V is to provide a master dictionary of data elements which support interoperability and common understanding of installation geospatial data for DoD worldwide, to standardize the Common Core geospatial datasets used across DoD for installation management, energy and environment missions, test and training range operations, and civil works, and to comply with DoD IT standards policy and governance mandates, including developing, registering, and publishing the standard in the form of a logical data model, which means it is vendor neutral and thus can be implemented in any commercial or open source GIS software today. SDSFIE-V is fundamentally structured in alignment with the DoD Real Property Information Model, or RPIM, and the Real Property Accountability Requirements. This promotes a core goal of IGINS, which is to provide a geospatial feature type in which key attribute data can be stored for each DoD real property asset. This is important for purposes such as real property accounting and reconciliation, and for maintenance cost forecasting. SDSFIE-V Gold is an enterprise-level versioned data model that contains the core entities, attributes, and pick lists defined by subject matter experts representing all IG components and their requirements. Lastly, each DoD component has the ability to build their own version, or adaptation, of the Gold model. These adaptations are tailored to component-specific business requirements and systems. This is a data modeling diagram, which is helpful in understanding the SDSFIE vector modeling process. The pyramidal shape represents an increasing level of detail moving from the top two tiers, where a more general conceptual model based on mission requirements and rules is defined, to a highly detailed and structured set of data tables, relationships, and rules that are implemented in a GIS at the bottom. At the top of this pyramid are the business mission areas. Here we determine the scope of what data is applicable to SDSFIE, and thus what the SDSFIE-V model and resulting GIS database will contain. Next, the Application Subject Matter Area Model, or ASAM level, organizes and groups the data defined above into the 14 distinct subject matter areas shown here. At the Logical Data Model, or LDM level, the specific structure of the IGINS and Civil Works requirements for data layers, or in modeling speak, entities, relationships between entities, attributes about each entity, and pick lists for certain attributes are defined. These model elements are established using documented modeling rules and best practices. These will be defined in greater detail in a later slide. Component-specific LDMs are developed from a version of the Consensus Core Gold SDSFIE-V model and then are reviewed and approved, at which point they can be expressed as, or transformed to, a physical data model, or PDM. The SDSFIE portal system provides for PDM download in either Excel workbook format, perhaps to serve as a local data dictionary, or in PDM spec format. The PDM spec file is used to transfer the logical schema of an SDSFIE-V data model to the GIS. An Esri geodatabase created in this manner is compliant to the approved LDM from which it is produced and is ready to accept data in the standardized format. It is important to point out that this discussion is about modeling and the structure of the data container, with no data involved. The population with records of points, lines, polygons, and associated tabular attribute data come into play when data is subsequently loaded into a compliant Esri geodatabase using workflows such as the SDSFIE portal's data migrator. In SDSFIE-V, models consist of a defined set of elements. One important part of DoD's Vaultus goal is interoperability. In the case of installation and Civil Works datasets, interoperability would mean that the data from different installations can be easily aggregated at the component level, and those aggregate data stores from different components can be seamlessly rolled up at the DoD level. To achieve this interoperability but provide flexibility for components, there is a model hierarchy within any version of the model. The Gold version is at the top of this structure, with component-specific models derived or adapted from the Gold parent. Components can then further tailor the model for specific elements of their organizations through the adaptation process, which will be explained in more detail later in this presentation. Both the Gold LDMs and their adaptations must adhere to the rules specified in the SDSFIE-V Implementation Guidance, or SVIG, to ensure interoperability. The SDSFIE Vector Implementation Guidance, or SVIG document, is our rulebook for creating and versioning our Vector Gold model and subsequent component adaptations, as well as the submittal requirements and review process. The SVIG specifies the model elements and their relationships, properties common to all types of elements, and rules about properties unique to each type of element. Additionally, the SVIG provides best practices for element naming and guidance for adding location, measurement, and unit of measure attributes. This is a detailed document, and we won't do a deep dive today. However, it is important to have this document on hand when building or reviewing an adaptation. Each version of the SVIG corresponds to a major release of the Gold model. A new version of the SVIG, version 5, is currently under review and is expected to be approved and published in conjunction with SDSFIE-V Gold version 5. For the SDSFIE-V Gold 4.0 release, the DoD published a memo on February 9, 2016, shown here at the lower right, that mandated the use of this version. It stated that SDSFIE-V implementation was required to be completed within 5 years, by the beginning of 2021. That ambitious goal was nearly met, with all components creating an adaptation of Gold by July 2021 and migrating their data to a geodatabase compliant to the standard by December 2021. Throughout that period of initial 4.0 vector implementation, there were a total of 5 releases of the Consensus Gold standard. These versions were produced just ahead of each component finalizing their adaptation of Gold, so as to encompass as many IG-approved Gold changes as possible. We expect the next significant release of Gold to be version 5.0. Each SDSFIE-V logical data model element is defined in the SFIG. These elements, presented in the table's right-hand column, have a direct correspondence to the first-class element objects in the Esri geodatabase model. The definitions of the SDSFIE-V LDM elements and the correspondence to the objects in the Esri physical model are as follows. A model is simply a specific collection of SDSFIE-V elements. In Esri ArcGIS, models are implemented as geodatabases. A folder is a set of feature types that are grouped together for database organizational purposes. In ArcGIS, this corresponds to a feature dataset. In SDSFIE-V, there are 2 types of entities. First, feature type represents a set of thematically equivalent features which can be expressed as records, or rows in a feature attribute table, that are linked to a geometric feature that is a point, line, or polygon. Second, object tables define a non-spatial data table that can be linked to one or more feature type records. In an Esri geodatabase, these elements are called feature classes and object classes. An attribute of a feature type is a characteristic of the features, and can be expressed as a column in a feature attribute table. In Esri, an attribute is called a field. An enumeration constrains an attribute to a permissible set or numerical range of values. In an Esri geodatabase, the synonymous term is domain. An enumerant is a value within an enumeration. The enumerants for an enumeration comprise the permissible set of values for that enumeration. In Esri, these are called domain values. An association is used to establish a relationship between 2 entities using a foreign key in one attribute table that points at the primary key of another entity. In an Esri geodatabase, this is called a relationship class. This table builds on columns 1 and 2 on the left that were presented in the last slide by adding a list of 6 standard properties that are applied to all types of elements, as shown in column 3. Among the standard properties, the alias is the common name, in English, of the element. The model name is typically the same as the alias if a single word, or if multiple words, a concatenation with no spaces. A definition is a characterization of the element, typically in 2 sentences and a paragraph at the most. A description is optional, and may be used to elaborate on the definition, to provide examples, and to list one or more alternative names for the element. A note, also optional, may be used to provide usage or implementation details, deconfliction information regarding similar terms or concepts, and/or relationships to other model elements. Finally, the justification property is where the rationale for existence of the element is stored, along with any references or citations. For example, any used in establishing the definition. Regarding model names, they are either Pascal case or camel case, depending on the element type. Pascal case, where the first letter of all words is capitalized, is used for folders, entities, enumerations, and associations. Camel case, like Pascal case, except without capitalizing the first letter of the first word, is used for attributes and enumerants. Of the standard properties, and according to the SVIG, it is the model name and the definition that make an element unique. Additionally, the text strings contained in these standard element property values are what is searched by the query algorithms in the Model Viewer application. The final addition to the table is an inserted column that contains element properties that are specific to particular types of elements. These element-specific properties augment the standard properties that we just covered. For example, the default and permissible vector geometry types must be defined for the SDSFIE-V entity element type. For feature types which have a spatial geometry, the point, line, and polygon values are used, with a value of none used for the non-spatial object tables. For attributes, several element-specific properties are required. First, and because of the hierarchical nature of this data model, where entities contain attributes and attributes are assigned to entities, the entity model name is a property that must be populated to understand where the attribute belongs. Second, because an attribute in the logical data model ultimately defines a field in a physical data table, the data type property, for example, text, integer, decimal, or date or time, and length property, are required. Third, the constraining enumeration property is required to be able to utilize a pick list for selecting from a valid set of values to populate an attribute. For enumerants, an enumeration model name property is required, again due to the hierarchical nature of this data model. The SFIE-V contains the full list of element properties for a particular model version. As stated, the SDSFIE consensus process leads our community to adopting an agreed-upon gold model that is mandated for component use through an adaptation process. This diagram will depict that process in a conceptual manner. The adaptation process consists of profiling, extending, and changing the elements of a parent model to create an adapted child model. The parent model depicted here has 6 entities, each represented by a dark rectangle. As we just learned about SDSFIE-V's hierarchical element structure, each of those 6 entities contain attributes, and some of those attributes may be constrained by an enumeration, which in turn contains a pick list of enumerant values. For components, the parent model for a new headquarters adaptation will typically be the most recent version of SDSFIE-V Gold. In cases of doing a simpler adaptation upgrade, the component's previous headquarters model serves as the parent for the adaptation. The first step in the process is to selectively profile elements from the parent model. The bubbles depict the selective profiling of elements, including entire feature types and object tables, as well as non-mandatory attributes, enumerations, and/or enumerants from the parent model. The result of profiling actions that include removing 3 entire entities and removing lower-level elements from within one of the retained entities is an intermediate profiled parent model. The next step in this process is to extend the profiled parent by adding elements that do not exist in the parent model. The next set of bubbles depict the selective extending of elements to the parent model. These extended elements can be entire feature types or object tables, as well as additional attributes, enumerations, or enumerants. The result of extending actions that include adding one entirely new entity and adding lower-level elements to one of the retained entities is the child adaptation. As mentioned, the SDSFIE-V Implementation Guidance, or SFIE-V, specifies the rules for adaptation actions. While not depicted in this diagram, components may customize their model through a number of allowable change actions. Components may change an alias name, add a note or description if one does not exist, or augment an existing note or description in any type of element. As mentioned, rules specific to particular elements must also be considered when developing an adaptation. For example, attributes can be decreased in length, and constraining enumerations can be added to attributes that are unconstrained in gold. All of the 3 main steps of the adaptation process, profile, extend, and change, allow a component the flexibility to shape the gold model to meet its unique mission requirements, while maintaining the consistency that ensures interoperability with the data from other components. The SDSFIE portal contains a set of resources that include web pages that provide background, governance, standard-specific information, and component-specific content, access to the Automated Process Portal, or APP, which is the online system that facilitates the Change Management Process, or CMP, access to support resources, such as recorded webinars, training videos, and user manuals, access to the suite of SDSFIE tools, most of which focus on the implementation of data models that are compliant to the vector standard, and in some cases the metadata standard. These web browser-based applications include the following. Model Viewer enables users to browse and search single or multiple models for key terms and/or phrases, and to optionally generate logical and physical representations of a model. Model Builder enables users to create a new model as an adaptation of an existing parent model. Model Comparator enables users to compare 2 logical models, a parent and an adaptation of that parent, and fully describes their similarities and differences at an elemental level. Model Validator verifies a model as an adaptation of a parent model using a rule set defined in the SDSFIE Vector Implementation Guidance, and provides a spreadsheet output listing all non-compliance findings. Data Migrator is an ArcGIS-based toolset supporting the migration of data from one adaptation of SDSFIE-V to another version of the same adaptation. ArcGIS Tools is a set of 3 downloadable tools that run in the Esri ArcGIS environment: the Geodatabase Creator, the Logical Data Model Creator, and the Geodatabase Comparator. This concludes the Understanding the Vector Standard training. If you want to learn about the SDSFIE program, SDSFIE governance and use, more about the SDSFIE vector model, or other detailed SDSFIE topics, visit our training resources page at the URL listed here. Note that the What is SDSFIE-V video, not listed here, is a condensed version of this video. Thank you for your interest in the SDSFIE program.